Welcome back everyone. In this video I'd like to give you a quick introduction to the lab that we're going to be doing and explain some of the calculations that you'll be making. So basically what we're doing in this unit is we're looking at something a little bit different, which is going to line up with what you'll be doing in chemistry. We're looking at gas laws, how do gases behave, and this is something that we can look at on both a macroscopic and microscopic level. So what I mean by that is macroscopic is large scale, and that's what we're going to be looking at in this experiment. We're going to have an apparatus kind of like what you see, where there's a syringe that's kind of upside down and it's marked off with different volumes in milliliters. And what we're going to do is we're going to apply pressure to the top of this by putting masses of various amounts. And so what we'll be doing basically is to try to determine, this is the purpose, a relationship between volume and pressure for a closed system. And so we talked about what a system was back when we did energy. A system is anything that we define, and in this lab the system is just going to be the apparatus. Okay, so the top and the bottom are to stabilize it, but there's a syringe, there is actually a cap on the bottom that you can't see, and then there's going to be air inside. Okay, so a couple of quick definitions. Well, volume is easy, we all know what volume is, but something to be aware of is that you're going to need to know how to get from milliliters into cubic meters. And so the conversion is this: 1 milliliter is the same thing as 1 cubic centimeter. Okay? But in order to convert that into cubic meters, we're going to have to take this and multiply by a conversion factor. We know that there are 100 centimeters in 1 meter, but in order to get centimeters cubed, we have to cube both the top and the bottom. Okay? So this ends up being, well, the centimeters cubed will cancel out, but not before the 100 gets cubed as well. Okay, so that centimeters cubed will get canceled out, and in the end what we get is that 1 milliliter is the same thing as 1 times 10 to the negative 6th cubic meters. Okay? And you can kind of visualize this. If you think of a box that is a meter long and wide and tall, you can fit about 1,000,000 sugar cubes in that. Those are about a centimeter cubed. Okay? So that's the first thing. The second thing is our definition of pressure. So we're going to say that pressure is force divided by area. Okay? And so P is equal to F over A. And most of the time the units of pressure are going to be the units of force, which are newtons, divided by the units of area. And this is surface area, so meters squared. Okay, now 1 Newton per meter squared also has the special name of the Pascal, or just simply PA. Okay? And we'll be talking about lots of comparisons between units, but this is what we need to do for the lab. And so when you go to measure the pressure, to calculate it, you're going to need to know the force which is pushing down on it. And so what we're going to do is take one of the discs that we used, like for the bridge competition, and that thing, for example, had a mass of 0.5 kilograms, and so that would have a force that it applies of mg, or 0.5 kilograms times 9.8, or that would give us a total of about 4.9 newtons. Okay? Then we would have to calculate the area. And we're talking about, here is the syringe again, okay? What we're talking about for the area is actually the top here, this opening. So it's like the top of a soda can, okay? And that area is going to be pi r squared. And the thing that you have to be careful of is that we want that to be in square meters. So if you measure that this thing has a diameter of, for example, 3.0 centimeters, well, you have to do two things. One, convert into a radius, and two, convert into meters. Then you can plug that into here and find the area. And then last but not least, you can find the pressure by dividing the two. So for example, if I happen to have an area, I'm just going to make this up, of 1 times 10 to the negative 4th meter squared, then my pressure in with these numbers would be 4.9 newtons divided by 1.0 times 10 to the negative 4th meters squared, or I think that is about 49,000 newtons per meter squared, or pascals. Okay, so that's the same thing. Alright, now what we're going to do in the lab is we're going to measure basically about 10 different pressures, and from that measure 10 different volumes. And we're going to try this a couple of times. And ultimately what we're going to come up with is a graph of pressure on the x-axis and volume on the y-axis. And then once we get that data, we're going to try to turn it into a straight line, which is going to be a topic of another video. But now let's pause and let's think about what we need to do to actually plot this data on Excel.